Hi, this is Tribble Solo again, your friendly neighborhood physics teacher. And what we're going to go over today very briefly is momentum and impulse in relation to a car crash. Now, we can't simulate that in the classroom, so we're going to use an egg, simulating impact as if it was one of us impacting into a wall, a vehicle collision into a wall. We're going to do it with an airbag simulation and without. We're going to do it first with the airbag simulation and then without. And then we're going to compare and contrast the data and come to some conclusions. And you can tell me what you learned. Okay, and there's a lot of reference material in the experimentation workbooks that we have, but basically what you're going to do is record what you see. Okay, I already went through this and I recorded the data here on my computer. We used, or we will be using, as I used here, is a data probe. Right over here is all of this information that was recorded over a 30-second period. You can change the amount of time that you want to record data, and our setup is going to be using your computers, and this is the motion detector. As you know, you saw this yesterday, has the clamp. Remember that this motion detector has to be at least 1.5 feet away from the motion that you want to record, but it can't be more than 6 feet or 6 meters actually, so it's more than 6 feet, but we don't have that much room in the classroom either, and you shouldn't be on top of one another. Okay, so this is the motion detector, and it connects easily into this data recorder. You can see the model. It's Lab Pro Go Motion, and I have it connected right now. You can see it's easily just plug and play. All of this is connected right into this computer. Okay, now you see the way the setup is, and we went over how to use these data probes yesterday, so now we're going to apply the knowledge that we learned yesterday into this experiment. Okay, here we go. This is what you're going to, I don't have enough cameras to show you the data and the experiment all together, so I'm doing it separately, almost like a cooking show. You know, they show you the finished product. The cake is already baked. Well, this is the data. Okay, and up here is the position recorded, and it varies. It's going up and down. Also, the velocity down here at the bottom, and again, it's varying. It's going up and down. And I did this several times during the 30-second period. The default goes to 5 seconds, so you want to change that. And then you can always. This is so simple because you can always then just delete the data and redo it again if you're not happy with the way the experiment went. Okay, so what I'm going to do first is I'm going to show you very simply, so you don't, I'm using 2 textbooks to give a little bit of an elevation angle. So 2 of these physics textbooks, you can use one of the earth science, whatever, doesn't matter, any textbooks will do. Well, we certainly have enough physics textbooks. So you can use 2 textbooks with the piece of the steady cardboard box. And we do have some pillows available. We have bubble wrap, and we also have what I'm using right now. I don't have enough of the same for everyone, but that's good because we'll be able to compare and contrast our results together, okay? So this is packing material. All right, so here we go. And the egg I initially used got so banged up from all the tries that I can't use it again. I have to get a and use a different egg this time to show you. Okay, here we go. Now, this is angled up, which you can't see down here. There's two textbooks, and this is like a cardboard box. Okay, this is the wall, and this is our simulated air bag. So what we're going to do is just make sure that everything's secure. The motion detector is clamped on. It's a motion detector, so you don't want to hold it. I know some of you think that you have steady hands, but it's very, very difficult to hold it steady, and you're measuring the motion of the egg. So let's go. And here we go. Oh, that wasn't so good. Let's try it again. Very good. So that's what we want to do. We want to try and hit it in the middle of this bag, because on the first try it went in between. That's almost like hitting the wall itself. There's really no cushioning here. Very, very slight. What happens is this, when the egg hits this airbag, the time of impact is increased. So it becomes spread out over the surface area. Okay, now if the airbag wasn't here, this could get very messy. So I'm going to put, as I told you, also you should be wearing gloves. I'm going to put this egg very slowly down this incline, which is not exactly what you want to do, but I just want you to see. We're going to say this is negligible, even though that's what I need to put this whole bag up like this, because it's going to get messy. Okay, so, well, I'm not going to hit it that hard. I don't have a big angle, so what I'm going to use is the egg again. Actually, let's do it like this. Let's just put it down like this, because I want it to be more of a real impact so you see it. Okay. Here we go. So you're just going to take the egg, put this down a bit so you can see it, and roll it. You heard that bang, right? If I did this one more time, it's going to crack, or if I didn't have this garbage bag here, I just don't want to do the messy cleanup now, and I'm going to get the oohs and the ahs and everything like that. But essentially, you see what I'm talking about. And this is going to show you, most of your eggs are going to crack on the second time. Mine did, and I don't want to clean up that mess again. So what we need to do is get into our groups and start the experiment and keep track of all the information. You know your thinking responsibilities. Okay, so get into your thinking responsibilities, get your equipment. I have to come around to make sure that I do a safety check to make sure that everything is in place and that you have all the equipment, everything's working before we begin. Don't worry, don't rush. When you rush is when you make mistakes and you have accidents. We can always continue this tomorrow, okay? So let's get started.